So today we're going to look at polar and nonpolar covalent molecules. You already have some background information on covalent molecules. Covalent molecules are formed when electrons are shared between two elements, and those elements are made up of nonmetals. So nonmetal elements generally will share their electrons, forming a covalent bond. So what we're going to determine is what is the difference between a polar and a nonpolar covalent molecule. Surprisingly, does not involve anything with bears. So bears are not involved. So polar covalent molecule is when we have electrons being shared unequally. So of course, sharing unequally means that one element is holding on to those electrons more than the other element is, and those electrons are closer to that element. And so therefore that molecule is going to end up with a negative and a positive end to that molecule. There's going to be a large difference in the element's electronegativities. You can find a list of electronegativities on page 194. You'll always be given them. You won't have to memorize them. But there's going to be a really big difference between one element's electronegativity and the other element's electronegativity. And if you remember from periodic trends, electronegativity is the ability to attract electrons from another element. And so we have one element with a high electronegativity, which means it has a high ability to attract electrons, and you have an element with a low electronegativity, which doesn't really have that much of an ability to attract the electrons. So when you're comparing those two, of course, the element with the high electronegativity is going to be able to have those electrons more, because if you think about this as unequal sharing, which means that they're still being shared, but one has them more than the other one. So the higher electronegativity is going to have those electrons more, which is going to give it a negative charge, because we know electrons are negative. So oxygen is an element that has a high electronegativity. It really wants those electrons. It has a high ability to attract those electrons. So oxygen would have a negative charge on it. Then the element with the lower electronegativity doesn't really want those electrons, and doesn't have that ability to attract those electrons. So therefore, they're not going to have the electrons as much in this sharing partnership, and so they are going to have a positive charge to them. Hydrogen is a great example of an element that has a lower electronegativity compared to oxygen. And when we compare them, the oxygen would have the electrons more, hydrogen would have the electrons less. How do we know that? We just look at their electronegativities. So a polar covalent molecule is represented by water, one of our favorite molecules. And why is it a polar covalent molecule? Because if you look at the electronegativity of oxygen and hydrogen, there's a large difference between them, and that difference is 1.2. Where did we get 1.2 from? Well, we looked up oxygen's electronegativity, which is 3.4, and we looked up hydrogen's electronegativity, 2.2. Like I said, this would just be on a chart. You'd be given this. You don't have to memorize these. And so all we do is subtract them. We find the difference between them, and that's considered to be a large difference. So anywhere between 0.5 and 2.1 would fall under the polar covalent range. So 1.2 falls in between that 0.5 and 2.1, so therefore we would consider that a polar covalent molecule. And so it's going to have a positive and negative end. Which end is negative? The oxygen end. Okay, so oxygen is going to be the negative, and hydrogen is going to be the positive, because it has the lower electronegativity. So the one with the higher electronegativity, which in this case is oxygen, it has electronegativity of 3.4. Hydrogen has electronegativity of 2.2. The higher one is negative, the lower one is positive. So then what does it mean to be nonpolar covalent, not nonpolar bear? A molecule in which electrons then are shared equally. So what would make it nonpolar? Well, there's no pole. There's no positive, no negative end to it. And in order to have a molecule like this, there's really no or very little difference in the element's electronegativity. So they both have the same ability to attract those electrons. Okay, so they're equally as cute, or equally as not so cute, thinking back to the cats. So carbon carbon has a lower electronegativity, 2.6. Hydrogen has a lower electronegativity, 2.2. So really there's very little difference between carbon and hydrogen. They both have about the same ability to attract electrons. And therefore that's going to be equal. Those electrons are going to be equally shared, and there's really no positive negative end on a molecule containing carbon and hydrogen. So we would say that that would be a non-polar molecule. Some other electronegativities, you'll notice that fluorine is the highest. Fluorine has the highest ability of any element on the entire periodic table to attract electrons. And the highest electronegativity we would have would be a 4.0. The only way fluorine will form a nonpolar molecule is if it's bonded with itself. If it's bonded with anything else, as you can see, oxygen would be the next highest. The difference is 0.5 between these two, and so therefore we're going to end up with a polar covalent molecule. So when we look at these electronegativities, all you have to do to figure out is it polar, nonpolar, is find the difference between the two. And there you go. That's it.